I have a question. Do we have any non-Polish speakers here? Okay, I'll continue in English then. Thanks for coming. All right, so recently I was thinking about how we do develop software. And I came up with an idea, with a conclusion, that vast majority of how I do create software, how I do create software is basically creating 3 layers of it. The very top of them is client application. It can be either web, mobile, desktop application, any kind of it. Then I'm consuming some kind of APIs, which is connected to some kind of data store, database, or maybe cloud data store. And what are the building blocks of those of that top layer client application? Maybe some kind, in some ways, API application, where we are using design patterns to organize our code and just to be a more and better programmer. And if we are speaking about design patterns, and especially if we are speaking about design patterns in UI applications, the king is only one. It's MVC. And I assume many of you are familiar with MVC, and you already know what is it. Just a quick reminder. So MVC is a design pattern that consists of 3 layers: view, controller, and model. View is responsible for displaying data and also for gathering user input. Then it passes those data to controller, and the controller saves it to the model, and also picking the data from the model and pass it to the view. Okay, so but what are the very basic building blocks of programming? Okay, sorry about that. First, MVC. Why MVC is so cool? MVC is so cool because it's super easy to understand. It's very intuitive. You just need 10 minutes and read one article, and you starting to know what MVC is. And also, it's the very first design pattern we learn. Actually, it was in my case, but I assume it's also your case. And MVC is used literally everywhere, sometimes in slightly different form. I mean, let's take, if you are a .NET programmer and you are programming in WPF, there's MVVM. It's model view model. It's slightly different, but basically it's kind of the same. If you are Angular programmer, in Angular they call it MVW, which is model view whatever. So you can put anything in controller space. So it's used almost everywhere. MVC is so popular. It's super cool. I loved MVC, but MVC has its flaws. The first flaw is MVC looks different than it looks on the schema. It looks different on real-world application. So this is very simple schema of 2 views, the filters view and transactions view. And we are starting to see that, hey, it's something different here, and what I saw here. They start talking to each other. Controllers start talking to each other. And it's not bad if there are not so many connections, but if our application starts to grow, we end up with something like this. And it's hard to scale, hard to maintain. It's also hard to understand. Yeah, so there's difficulties with scaling MVC is also the flaw. And also, communication between the layers is bidirectional, which means my layer, it doesn't matter what layer, if it's model, controller, or view, needs to understand and needs to communicate in both directions. I mean, it needs to learn how to send data to the next layer and also how to receive data from that layer. And it can be hard. Imagine the controller. It needs to communicate with view and the model. Okay, so we went through how systems can be organized, and that we are using design patterns to help us organize that code. But what are the building blocks of it? Every one of us is using programming languages. And in most cases, we are using paradigm that is called imperative programming. And imperative programming is also very cool. But what is imperative programming? So in imperative programming, it's a paradigm that we control every step of execution. We need to literally tell the computer how to code and what needs to be done, and exactly in which way it needs to be done. Also, I love imperative programming because it's the very first way of programming style I've ever learned. And as MVC, it's super easy to understand, it's intuitive, and actually it's used almost everywhere. If you don't know, or if you are not aware of which paradigm of programming you are using, I bet in most cases you are using imperative programming. But it also has some flaws. Having the control of writing, the code, having the control of that code means that we also are responsible for getting the right results. And we need to step by step explain how to go from point A to point B, because there's no other way the computer can understand. And assume a very simple example. Let's say we are creating an exchange application, currency exchange application, and we are getting some input from the user, amount in dollars, and we are getting from the external service exchange rate, and we want to calculate how much zlotys our client will get. So it's super easy, yeah? We need to multiply those two values, and we're getting the results. But what if exchange rate changes? What is the value of amount in PLN variable? It's still the old value. We need to tell the computer, hey, you need to recalculate once again. But we already know that those equation is always true. Like amount in any currency will always, we can always calculate it that way by multiplying those two values. It will never change. The values can change, but the formula will never change. But in this way, we need to recalculate it once again. We probably will put it in some kind of function, but we need to still invoke that function. Okay, so are there other ways to do things? Of course, yes. And that other way is functional reactive programming. It's not the only other way. There are other ways, but it's one of them. And there are many definitions of what is reactive programming and what is not reactive programming. My favorite definition is that reactive programming is async data streams. So you create data streams which are async. What I mean by that? And what can be that data stream? So the data stream can be just simple value changes. So if my variable changes value, I will emit new values to the stream. So in this case, we are changing the value from 1 to 0, then to 2, and then to 4. It can be also events. So if user clicks anywhere in my application, I can emit a new value to the stream. And I can use things learned from functional programming called operators. I can modify that value. I can, for example, filter the value in my streams. So let's say I can filter out any clicks outside given rectangle. And also, I can do all those things in one time. So how would our application, our currency exchange application, how it would look like if I would like to model it using the stream? So imagine the very top stream is the user input. So users inputs that it wants to exchange, let's say $100, then it's changed to $200, and then it's changed to $300. And the second top stream is actually the exchange rate. I can combine those two, and in every moment that any of those streams emits new value, I can emit new value that will, and it's here. Okay, yeah, I can emit new value that will that will contain those two. So I will have both exchange rate and end user input. And then I can map it to calculate the results. Okay, enough talking. Let's start with coding. So you better can understand what I mean by that. Okay, so I have prepared some very simple applications. We have transactions, and we want to display those transactions and enable user to filter it. So let's start coding. I have cheat sheet, so no worries, everything should be fine. But I will look into it, so it's not like I'm looking somewhere there, I'm looking on the cheat sheet. Okay, so first we need to create stream, because in reactive programming everything is a stream. So let's create a transaction stream. And I'm using JavaScript here and a library called RxJS, but that library is available for all other languages, like mainstream languages, for Java, for .NET. You will find it. I'll also put that into my presentation, and we'll share it at the end of it. Okay, so let's start coding. Okay, so here I have created a new stream. So let's try to display the values of that stream. In order to do that, I need to subscribe to that stream. And I will get transactions and just render it. Okay, let's see if it's working. Of course not. Yeah, for each is not a function. That's why I have prepared the cheat sheet. Yep, you're right. Thank you. Yep, okay. So here we have transactions there displayed. So let's now try to filter them. I would like to put here a category name and only show matching transactions. So in order to do that, I can create another stream. I can create a stream called, let's say, selected category. And that $sign at the end is just a convention. So I can create a stream from event. Okay, up. Okay, and let's see what are the values in that stream. So again, we need to subscribe to that stream. And just do the console log. Okay, so right now if I press any key, a new event is emitted. But I don't need an event. I need the user input in that field. So what should I do? It turns out that every event has a value have a property that is called target. And in target, there's another property very right at the bottom called value. So I can use that value and I will get the selected category. All right, so what needs to be done? Oh, sorry, okay. I need to modify that stream. And we can do this using the pipe function and map operator. So I need every event, from every event, which here is called, all right, so for every event, I will look for the value called event.target.value. Let's reload it. And now my stream is displaying different values, but still it's not what I needed to have, because I would like my user to have time to enter the whole value and not emit events every time he or she presses the key. So let's wait. Let's give our user some time. And you know what? There's another operator that can be useful in here, and it's called the bounce time. And let's wait 500 milliseconds for users. Okay, and let's check it out right now. Food. All right, I have my category. Okay, so right now I need to combine those two streams, the transactions feed and also the selected category. Okay, so let's do this. And there's an operator to do this, which is called combine latest. Combine latest. Sorry, it's not like that. And we need to pass the second stream that we want to combine. Okay, so it's selected category, and just for a moment, just for the sake of this presentation, let's comment it out and display the values in that stream, because it will not longer be a transaction. So let's see how it looks right now. And we have no values. Okay. All right, so let's move on. Not waste time. I will use another cheat sheet that I prepared. All right, so we've combined the values and also apply a map operator just to filter out the transaction that will match the selected value. And we also need to subscribe to that stream. All right, let's see it in action. Okay, no worries. And ta-da! All right, so let's see in action. Yeah, I can filter it out just by using few streams and few operators. And what is cool in that approach, I'm not saying that I need to, let's say, how it needs to be done. I'm just saying, hey, I need the values to be filtered. And you know what? You take the care of it. It's like with SQL language. When we query the database, we're not saying to the computer, hey, you need to filter it that way, and you need to select the values in that way. We're just saying, hey, select all values that matching that criteria and filter it that way and sort it that way. We don't get into the implementation details, and that's how it's cool in what is cool in reactive programming. Okay, let's move on. So to sum up, in functional reactive programming, we are saying what needs to be done instead of how it needs to be done, because we are interested in results instead of instructions. And what about MVC? Remember we talked about it, that it's hard to scale and it's also bidirectional. And are there any other approaches? Yes. Unfortunately, the answer is Flux. Flux is a design pattern invented by Facebook engineers who were struggling the same problems, which is we need an architecture that scales, and also preferably it's unidirectional. And in Flux, we have 4 items. It's action, dispatcher, store, and view. Let's have a quick look on every one of them. So the store is kind of like the model in MVC. It holds the state of an application, but in opposite to MVC, data in the store must only be mutated by responding to an action. There's no any other direct changes to the store. If you want to change the data in the store, you need to dispatch an action, and every time a stored data changes, it must emit a change event. If it's event, then I can create a stream on it, and I can observe that streams of changing data in my store. And how can the store looks like? You can see it here. So right here we have the users and selected users, and we can do a lot of crazy things with it, like adding users, selecting users, removing users. All right, and the view can subscribe to that event after mentioned, emitted by the store, re-render. So every time a store emits new event, I will re-render my view, and therefore I can display new updated values. And when users want to interact with my application, and maybe if he wants to change the state of the application, I will dispatch an action. And action is just intention to change application state. In JavaScript, it's just a simple object. Actually, in every language programming that is using Flux, it's just a simple object which has two properties, type and payload. So if I want to add users, the payload of that action would be data of that new user. And also it defines the internal API of application. All right, and so we have actions, we have store, we have views. We also need one more thing, which is called dispatcher. And dispatcher is like a middleman. It takes the action and it passes it to the store. And technically speaking, it's just a function which has two arguments: state, the current state, and the action that we want to apply to that state. And in return, it returns a new state of our application. So in that case, if I want to add user, I will return new array which has that new user inside it. So the good things in Flux is that it has unidirectional data flow, because if we go back here, data flows only in one direction, which is here. Also, we can have an action from different places, like in response to API. In response to API request, when the response came in, it also can change the state. And yeah, so this is good in Flux. It's unidirectional data flow. It works pretty well with reactive concept, because we can create streams and manipulate those streams. And there's a popular implementation. If you have a web background, you're probably familiar with Redux. So Redux is implementation of that architecture. But it also has some disadvantages. It adds a lot of boilerplate code to our application. So it's not like I can change the state. In order to change the state, I need to create new action. I need to handle that action, which is also adding complexity to the application. And when you think about, hey, should I use Redux? Should I use Flux? I highly recommend read that article by Dan Abramov. Dan Abramov is a creator of React library, and also contributor to Redux. That you might not need Redux, and Redux is not, hey, let's use Redux everywhere because it will solve all our problems. No, it won't. It will just solve some of them, but create different ones. All right, so to answer the question from the title, is it the end of MVC? I don't think so. I don't think so, because MVC is so popular and so easy and so available that I think it has a bright future. But reactive programming is coming. Here you can see a trend for phrase reactive programming. It's getting more and more popular. If you are, let's say, Angular developer, there's a you can program using this reactive paradigm, and it's supported by Angular by default. Now, for example, the forms in Angular should be or could be programmed that way, using the reactive way. And yes, so if you like to learn more about reactive programming, I highly recommend those 3 pages. reactivex.io, where you can find all libraries to also different languages than JavaScript. Rx Marbles, where you can learn the diagrams, how the operators works, and also learn Rx.js. And at the very, very end of the presentation, I think it's a good time to introduce myself. I'm Michal Jawulski, and I work as a senior software engineer in Capgemini, whatever you call it. I like to refer myself as a professional code reader, not a writer, because for most of my daily work, I read the code, don't write it. And if you like that presentation, you can follow me on Twitter. That's my Twitter handle. And I have a small request to you guys. If you liked it, please send me a feedback. If you don't like it, don't do it. Just joking. Also, any kind of feedback is highly appreciated. You can do it here on Twitter, or you can just come to me and say what you want to say. And that would be all. Thank you.